Hey boys and girls, Mr. D here. Uh, Continuing on looking at inequalities here, solving for variables, graphing them. Here we're going to look at compound inequalities, which means there's more than one part to it. Okay, so if we take a look at our example 1, if you look, we've got really what we have here, 17 less than 2x plus 7, which is less than or equal to 29. One way to think about this is we really have two inequalities. So it's 17 less than 2x plus 7 and 2x plus 7 is less than or equal to 29. Okay, so we're going to solve and we'll graph these. Please make sure you take note. One of the biggest differences you'll see between a couple of the examples here, the first two examples, is this word right here, and. All right, notice what the word and will do for us. It creates this situation here. So let's see what we've got here. We're going to solve one at a time. Excuse me. We'll just solve one at a time. So in this situation, we all know at this point, we should know at least, we'll get the variable alone, subtract 7 from both sides. We have 10 less than 2x. Okay, here we'll divide by 2. And we should end up with x is greater than 5. Okay, let's come over here and work this part. Again, 2x plus 7. Let's subtract 7 from both sides. Okay, so here we have 2x less than or equal to 22. Divide by 2, and x would be less than or equal to 11. Now, if we go to put these on a number line, you guys can use your ruler. Let's do this here. So, here's my 0. I need x that's bigger than 5. Actually, let's move our 0 over just a little bit. I'm just realizing the numbers we got here. So let's just say 0 is over here. All right, and 1, come on, big guy. 1, 2, 3, 4, 5. That will go up 6, 7, 8, 9, 10. Here's 11. Okay, so here's our boundaries. Now, again, if you look at these signs here, this one has the equal sign, so that one will be colored in. This one does not have the equal sign with it, so we'll keep that one open. What we're saying here is x has to be bigger than 5, and it also has to be less than 11, or equal to 11. So we color in this area right in here. That would be our shaded area. Okay. Take a second. Draw on your number line correctly. If you need to press pause, and then we'll move on to example 2. But notice when we have and, okay, it's got to fit both criteria. It has to be greater than 5, and it also has to be less than 11. It's got to fit both criteria. Okay, let's take a look at example 2. Example 2, notice we don't have the word and, now we have the word or. So you're going to have to meet one or the other. Okay, so it's still two problems. We'll solve it as such. Plus 1, 3n greater than 9, divide by 3. We get n is greater than 3. Or we could have this one over here. Go plus 1. Oh, sorry. I'm rushing here. You guys are all probably yelling at me at home, or just making sure you guys are paying attention. We should subtract 3. Alright, so we got 4n less than negative 4. Just to separate those two, okay? Here we'll divide by 4 to get our n all by itself. N less than negative 1. So if you look what we've got here, we're going to put this on a number line. Again, please use a ruler. Keep your number line nice and straight. Right? So we have an either-or situation. So if you look here, we need n greater than 3. Not greater than or equal to, but greater than. So we'll keep that open circle. And here's where I'll be going to. It'll go all the way up to infinity. Okay. Or it could be n can be smaller than negative 1. Again, no equal sign underneath it, so we'll keep it as an open circle. Smaller than negative 1 goes this way all the way to negative infinity. So again, notice two different setups. It's either or. And really, if you think about this logically, boys and girls, there's no way it can fit both of these criteria. You can't have a number that's bigger than 3 and less than negative 1. Whereas if you go back and look at this other graph, you can definitely meet criteria. You could be less than 11 and bigger than 5. Okay? So you got to meet both in this case. So notice it's a middle graph that's colored in here for an and. When we have an or, it's going to split and go in opposite directions where it's literally impossible to meet both of these criteria. Okay? We'll do some more practice with those in class. Let's take a look at another example here. Now they want us to write this interval as an inequality. So they're giving us the interval. They're saying, we haven't really seen anything written like this yet. So let's take a closer look here, what they're actually telling us. Okay. So they're starting at 4. Now notice the difference between these parentheses. This is a bracket, this is a parentheses. When we see this bracket here, we see this bracket right here, that means we color in that circle. That means this solution includes 4, which means we should be coloring in that circle. Infinity, technically we can never get to infinity, so anytime we have infinity, it'll always be what we call, say, open. All right, so here they want to know from 4 to positive infinity. So that's how we would do it. That's what it would look like on a graph. If we want to write it as an inequality, well, then we would say x is greater than or equal to 4, and that's really it. Okay. If you also want to, you could put this over here as well. We don't necessarily need this last component. Okay. So here's the graph. Here's what it would look like as an inequality. Again, we don't necessarily need this last component. It's sort of understood that it goes all the way up to infinity if x is bigger than 4. Okay. So we can just leave it as that. We're going from positive 4, which is included in our solution right here, all the way to infinity. Take a look at this one. We have an or. I see an or. You should start to get an idea that if we were to graph it, it would be something like this, going to different ends. That we're going to have with different equations like this, different inequalities. So let's take a look. Or, let's start with our number line. So negative infinity is right here. Down that way. Let's give us a 0 here. Negative 1, negative 2. And if you look, negative 2 is included in our solution set because it's got that closed bracket. And we go all the way to negative infinity. Okay. Here we've got starting at 4, 2, 3, 4. And if you look carefully, 4 is not included in our solution here. It's got that open bracket. It's got this parenthesis, regular parenthesis, so it's not included. So this will be an open circle. And it's going to go all the way to positive infinity. So that's what it would look like on a graph. They want us to put it into an inequality. Well, we would say x is smaller or less than or equal to negative 2, or x has to be greater than 4. All right, all these x's, all these solutions are bigger than 4. All these solutions are bigger than negative 2. do some more practice with these, but again, these are called compound inequalities, and hopefully you feel pretty good with them. We'll hit on some practice with these when we get back into school. See you guys then.